All right, here's two questions that deal with gas laws. And, uh, um, and I've had a couple of these questions. And I guess one of the questions that students ask is, well, which of these laws over here do I have to use? Whoops, where's my pencil? So which of these laws do I have to use? So is it Boyle's law? Inverse relationship between pressure and volume? Is it Charles' law? Is it Avogadro's law? Or Guy-Lussac's law? Or is it this combined gas law at the end? So which of those do you use? Well, I guess it depends on what they give you and what the unknown is. So if they tell you, like in this question, they say, what's the pressure? Well, I have to use one of these laws that has a pressure in it. So there's pressure, here's pressure, and there's pressure. But which of those three do I use? Again, it depends on what they give you. So I'm going to do two questions, and hopefully it can narrow down how you decide which formula to use. So the first question says the volume of a container is 4 liters. So the initial volume, 4 liters. And as the pressure is 63.2 psi. It now has a volume of 8.4 liters, so 8.4 liters. And what is the pressure? Okay, so if they don't say that the temperature and the number of moles don't change, you can assume that. But if they don't say that, then these are a wash. If they don't change, then I don't need to use those at all in a formula. So the formula I'm looking for is one that just has pressure and volume in it. So that would be Boyle's law. I'm not going to do the whole question. I'll just manipulate, plug it in, and you can go from there. So in this case, we're looking for P2. That's this one. So I want to get rid of the V2, so I'll divide both sides by V2. V2. So these cancel out. So P2 is equal to P1 V1 over V2. And then I'll plug my numbers in. Pressure, first one is 63.2 psi. Volume 1, 4 liters. Final volume 8.4 liters. I'd multiply and divide. Now the liters cancel, so my answer will come out in psi. I think in the question it asks for what is atmospheres. So then I'd have to do the next part of the question. Well, next part of the question would be to take this, my answer in psi, this answer from there, and multiply it by a ratio to get rid of the psi. I want to go to atmosphere, so the conversion unit is 14.69 psi is the same as 1.00 atmospheres. So the psi's cancel, and that would change things to atmospheres for you. The important thing, though, what I was really wanting to show from this question was how to pick the right formula. Let's try another one. So this one says 500 liters of gas. So 500 liters of gas, so that's a volume. So 500.0 liters are prepared at 700 millimeters of mercury. That's a pressure, 700 millimeters of mercury. And they're at 200 Celsius. Okay, that's Celsius again. So 200 plus 273.15 would be 473.15. That's my initial temperature. 473.15 Kelvin. The gas is placed in a tank under high pressure. When the tank cools to 20 degrees, another one, okay, 273.15 plus 20, 293.15. So that's temperature 2, 293.15. The pressure of the gas is 30 atmospheres. Oh, great. So this is measured in millimeters of mercury, and now they're giving me something in atmospheres. I've got to convert that too. So they say 30 atmospheres multiplied by 1.000 atmospheres is the same as 760.0, I think, millimeters of mercury. Okay, so I got to go 30 times 760. Let me just do that. 0, 18, 22. I think I need another 0 because it was 30. That's a lot of millimeters of mercury. 22,800 millimeters of mercury. That's my new pressure. Now, nowhere do they say they added more gas or gas got lost. So moles is how much gas. So it didn't change, so I don't need to use that in the formula. Okay, so I need a formula that includes pressure, volume, and temperature. All of these ones just compare two things. So I'm going to have to use this formula down there at the bottom. The thing is, it's got moles in it. Now, if it has moles in it, and it doesn't really matter with any of the units, if that property of the gas remains constant, what you can do is just forget about it. Another way of thinking about it is you can say, well, let's say the number of moles is 50, but if it doesn't change and this is 50 over there, that's the exact same number, so it's a wash, so I don't need to write anything in there. So I can rewrite that formula just to be P1V1 over T1 equals P2V2 over T2. And here I'm looking for volume 2, that's right there. So volume 2 is going to be equal to this cross, right there. So P1V1 T2 divided by the other stuff that's in this cross. Now V2 is already taken, so I just need to include the other 2 there. So that's T1 and P2. Okay. It's sort of hard to manipulate that. Once you get onto this ratio thing, it goes okay, but the 1s and the 2s and the P's and the V's and the T's, you can get those mixed up. Okay, so volume 2 is equal to pressure 1, and always go back and read off, match this with this. Okay, times V1, there's V1, 500 liters, times T2, 293.15 Kelvin, over temperature 1, 473. That's a common mistake that students mix those up. Times P2, 22,800 millimeters of mercury. I always write my units in because then I can go back and say, there's a, whoops. I can go back and say, there's a millimeter of mercury, and there's a millimeter, gone. Here's a Kelvin, there's a Kelvin. I wind up with liters as my unit. I'm looking for volume, life is good. Multiply and divide, come up with liters. Okay, why don't I give you one more question? Just one more. I'm actually going to take and, can I do this? Oh, it doesn't let me do it. Okay, I need to grab these formulas. I'll grab this stuff. I'll delete some things. Okay. Copy. Intro. Paste. All right. So I'm going to get rid of this question and this stuff. I don't need. Good. All right. So let me make up another question. So the volume of a gas is 500 millimeters of mercury, 500 point, at 300.0 Kelvin. Yeah. If the temperature increases to 350 Kelvin, new pressure? Okay, so I want to be able to determine which formula to use. So volume, I said the volume of a jar is 500 millimeters of mercury. Let's change that. Whoops. Making questions on the fly. Pressure of a jar is 500 millimeters at that. If the temperature increases to that, find the new pressure. Okay, so the pressure is 500 millimeters of mercury, and it's at 300 Kelvin. If the temperature increases to 350 Kelvin, find the new pressure. Okay, so the volume of this container must not have changed, so volume's out. It doesn't say a lost gas or gained gas, so the moles are out. So I need to find a formula that includes pressure and temperature. No. Oh, right there. Gay-Lussac's law. Now this one also includes pressure and temperature, but when you look, if volume is a wash, I don't need to write it. And if moles are a wash, I don't need to write them. But notice that the formula they have now here is the exact same as Gay-Lussac's law. So P1, over T1 equals P2 over T2. I'm looking for P2, so P2 is equal to the other cross, P1 T2, divided by the other thing that's across from what I'm looking for, T1. Plug stuff in, figure things out. Hopefully that helps you out to sort of determine how to choose which formula that you need to use in order to solve the question.